What page am I on? Page 151. Everyone there? Everyone on it? All right. Says use the scatter plot below related to outdoor temperatures and electric bill. So it looks like on the X, the horizontal, we have the temperature from 30 to 80 degrees. On the Y axis, we're using the cost of the bill. It appears that the higher the temperature, the lower our electric bill. So I guess this might be in the winter if you have an electric heater, I guess. I don't know. So explanatory variable. Explanatory EX, X value. So explanatory variable for that would have to be temperature. Response would be the bill. Pretty simple, I think. Describe the association of the two variables in context. I would say that it is maybe a moderate negative or negative moderate. And then it says estimate the correlation. The correlation, the R value number 4, I would say negative 0.4, negative 0.5, negative 0.6, somewhere in there. Ballparking it. I mean, I might not be exact there, but somewhere in that region. Does that make sense so far? All right. Can I move up? You getting those answers down? All right. Predict the response variable if the explanatory variable is 70. Okay. So what we want to do on here, this won't show up on the video, but it'll make it work. So they wanted us to start at 70. Agree? So what I'm going to do is I'm going to come up to my line of best fit. And then I'm going to draw best I can a horizontal line over here. So I think 39, 40-ish would be the price of our bill. We did that correctly. Okay? And it's just basically coming from the value they have, going straight up to the line of best fit, and then drawing a horizontal back across. Pretend I can draw a really good horizontal line. Okay? And then that one was explain what this means in the context of the question. So that would have meant that if the temperature was 70 degrees outside, we would expect to have a electric bill of roughly $40, give or take. Okay? So, and being that was inside our data, it's extrapolation. That's a good thing. Again, our line of best fit, doesn't matter what our equation is. The line of best fit is our predictor. Okay, even if we have a data point that's there. And then, how many observations are above the regression line? Okay, so if you come up here and count, and you say, I got 1, 2, 3, 4, 5, 6, I think that's 7, 8, 9. Looks like I have 10 of them above. Okay, so if I have 10 above, how many observations are below? The ones that are below, we'll do them blue. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 below. Okay? So you're not counting the ones that are on the line, the actual line itself. And then explain what those okay. Okay. So for the ones that are above, y hat equals mx plus b, which is this line, okay? That's what we use to predict. The ones that are in black, when they're above, means that I underpredict the data, okay? Okay, meaning like if I came exactly to, say, right here, where I was looking here, this value here has a positive. It's positive because it's above it. So you would expect to pay this much here, but you really paid this much here. So our line of best fit would be an under prediction based on that particular point. If you go down to the ones that are on the blue underneath, this means that my blue values down here, an over prediction. So over predict from the data, something like that. Okay. So again, so if I chose, say, this point here, if I use this as my predictor, I actually predicted I used more than I should have. So if you're working for a company and they're looking at the power bills and you're like, okay, anytime it's, what's today's temperature? Like 82, 83 roughly. So let's say we're going on the prediction that it's in the 80s. And let's say today was only in the 70s. I definitely am not using my AC to cool the building down as much. So those are things that could happen. Oh, good, the vape detector's going off. I'm safe. All right. So let's delete that. And then it says how many predictions are on the regression line. So if I come back here, how many are on the line? It looks like I have one or two that are on the line. That means my prediction versus what the data actually was spent were the exact same. Okay, we were spot on. Okay, but it doesn't mean that we did something wrong if we have data points that are above and data points that are below. You're collecting data based on the information that you have. You create a prediction model, your line of best fit. You use that little hat on top. Of course, when you use decimals, you don't have a hat that you use. You just know that if I have an equation I'm using to predict, it's going to be labeled with a Y with a hat on top of it. Okay, don't worry that you can't put a hat on top of it when you're plugging into decimals. Okay, so we got that. And then on the next page, page 152, use the same scatter plot on the previous page for each. Find the data point that represents the largest value of the response and call this point A. Okay, so largest response. Okay, so if we're looking at our, excuse me, having dots already there.
Why is the sound so delayed?
I don't know. My pulse is weak. All right, biggest response. Okay, I would say a response would be using our Y hat. And the question said, find the data point that represents the largest value of the response variable. Okay, the response variable is the Y, so our response is over here. So we're looking for the biggest distance. So that right there is pretty big distance. This is a little bit bigger. I would say this one has to be labeled A because this vertical line is bigger than the other vertical line, even though it's below it versus above it. And then it says, interpret point A in the context of the question. So this was point A right here. Okay, so this would have meant I would have over predicted how much my power bill would have been when my data on that particular day showed underneath it. So this meant, this right here would have meant I would have spent more money than this would have cost me. This would have been a lesser amount of money. Okay? And then let's see. Find the data point that represents the smallest value of the response variable and label that B. So we're going to look for the one that's closest to the line but not being exactly on the line.
Start up on the wrong page.
Am I?
The other one.
Oh,
That one. There you go. Good job.
jeez. I love you. It's like, what the hell is this guy doing? We don't know. Just let him go. He's talking.
Yeah.
All right. So the smallest response. So I guess that last one. This probably would have been the biggest vertical distance. This one also is probably just about the same size. So that basically means I had to go back and write the other question. I would say we could label this one A or this one A. Okay, that would have meant that my line of best fit, which is y hat equals mx plus b. This would have meant, because both those values are above the line. Oh, no, that's not big enough. All right. So basically, that just means I was predicting this, and I spent this, or I was predicting this, and I spent this. That means, in this case, it's going to prediction. So I went back to that one. I thought I was being so clever with it. And then the smallest value probably would be right here. We're going to call that B. Okay, and we still over predicted. I mean, you might be able to get away with this one as well. So one could have been an over prediction, one could have been an under prediction, just depending upon what we're looking at. But again, you're using the equation that's given to you when you plug in your data. Go ahead.
Wait.
I was on the wrong page on
I know,
one. Okay.
but wouldn't the largest value only be the one that is 56? Because given all the distance from the line are about the same, it's still lower. It's only about 50 or 49.
Oh, so you're saying this?
Yeah.
So because that would be above 55, is that what you're thinking? Interesting.
Because you're not measuring, are you measuring the distance from the line?
I would just go on the distance from the line of best fit, not the.
From just 0?
Yeah. So let me see.
So based on the question, so the exact wording of the question is find the data point that represents the largest value of the response variable.
Oh.
That only applies to that top one.
I would go with that. That's one of those that you definitely get. If I look at it one way and you come in and see me, I'll give you full points back. Yeah, I like that. And where else are we going? All right. Find the data point that represents the largest residual, the worst prediction. The largest residual, so that would be the furthest from the line, whether it's above or below. That's that. I don't know. I think both of those would probably have 47. So 56 minus 47. So that's 9. Speed distance of 9. This one, 47's up here. Maybe 39. So that's 8. So, and my distances might be off. I mean, they're so darn close. I mean, I think if you picked either one of those, you'd probably be okay. Because again, I don't know the exact values. I mean, the red is what it is. So, what does it say? It says, label those points C. Find the data point that is the smallest residual. So the smallest residual is, I guess when you say smallest residual, do you think if the residual is 0, that counts? I'd say yes. You could probably say the data points that are on the actual line have the smallest residual because the smallest number is 0. Okay, as far as the distance goes. So that basically meant that your prediction was spot on to what your data showed. You spent exactly what you would have thought you would have spent based on your data. All right. Now let's go to this problem. All right. Delete that. 1718. All right. Use a scatter plot pertaining to Major League Baseball. Says payroll in millions and based on the wins. Okay. So it looks like they're trying to say the more you pay your players, the more wins you get, which isn't always true because I definitely have scatter plots above and below it with our line of best fit. Assuming you own a baseball team, would you rather your baseball team be above or below the regression? So would I rather have my data up here, or would I rather have my data down here? Pink or green? Green. The green basically means that we use our line of best fit as to predict what our wins should be when we pay a certain amount of money. If I am underneath my data, that means the prediction was this. I have actually paid less than that and had a better team because I paid less. Is that always true? Does money often impact? Do you guys know what money does? Yeah. Okay. On I understand. I'm good with it. So they've actually shown this. So let's say you are working a job. Let's say you had an increase in pay and then production. Okay, we just had yeah.
Wait, you said green, right? For the,
Was that the one that was below?
yeah.
Yeah.
Wouldn't you want it in pink because that means you're winning more?
You're winning more, but on your line of best fit, anything above the line means you paid more. You didn't really necessarily have more wins.
But if you're above it, doesn't that mean you're winning more than you're expected to? Because the bottom is.
Was it pay wins? Is that what it was? Pay was here?
Yeah, pay was bottom and wins was on the side. So, but your wins would be the dependent and your payroll would be the independent because you can change how much you're paying.
Let me go back to it.
So you could, doesn't matter, you could have your payment at a certain price, I guess, and then you win more than you expected. I don't know how to explain it.
No, I'm with you. I love it. Okay, so hang on, let's think about it. So we're paying more money as I go this way, and then the wins up here, and which one did I have pink?
You had pink up top.
Pink up top?
Yeah.
Pink up there, green down here. Let's see. So you're basically saying like this guy's probably pretty happy because they're getting more wins and they're out in the middle of the bunch, even though they're above the line. Yeah. So vertically, more wins. I'm getting more wins. So it almost seems like if you're in this region up here,
You're pretty happy.
that would, yeah. Huh. I'd go with that. Go with that. All right, let's clear that.
Doesn't it really just come down to which one is the independent and which one is the dependent?
Yeah, a lot of times it would.
Okay.
All right, so whiteboard. So, friends, there was just a big strike on the East Coast. All of the people who worked on the docks went on strike. Okay. Now they're paying them more money. You want to know what's going to show with their productivity? It's basically going to have like an original hump. And it's going to go back to that. So it means it regresses back to the mean. So more pay might show an initial spike in your production, but then people are people, right? You go back to your normal working habits. Your 15-minute coffee break or your 45-minute lunch or whatever it might be. Yeah, you might show in the beginning where people are like, dude, they're paying us more, so I might only take a 50-minute lunch versus an hour lunch or whatever. But what really happens is as you increase pay, it doesn't necessarily change in the long haul of your stuff. And that's, Walmart. Walmart is a classic company that pays their people very low because they just kind of peter at this level. Okay, they don't necessarily show a dip. Okay, if Walmart increased this, you might have an initial hump where people are happy, but then it's going to go back to being just flat again. So, real life situation. Don't get me wrong. People want to pay me more for what I do. I'm okay with it. Doesn't mean I'm going to sit there and jump up and do more and more and more stuff. And that's human nature. That's not because we're being wrong about things. All right, let's go back to source. All right, what does this association say to you about the subject? What features of the scatter plot you look like? Well, even though our y hat, this line of best fit, even though this shows that as you go outward, you have a huge cluster of all of these teams. Some are above, some are below our predicted values. But I kind of feel like this team would be like the Yankees. Okay, the Yankees are probably one of the highest paid organizations. Yes, they've had a couple of incredible runs. But you think the owners of the Yankees are like, great, we're going to pay more and more and more money to keep having a more and more winning program. And it's like, oh, you're not making the World Series. Well, you're paying us more money. Okay. I actually don't follow professional baseball anymore. I don't follow a lot of pro sports these days because I don't like how money has perverted it. When I first started, growing up in Arizona, we had one sports team for the longest time. We had the Phoenix Suns, the basketball program. The Phoenix Suns used to play at Veterans Coliseum, which is down on McDowell and Grand Avenue. And it was a small little arena. And I kid you not, they knew that there were certain basketball games that people weren't going to go to because both teams were pretty bad. So you used to be able to go to 7-Eleven or Circle K, and they'd give you free upper level tickets to go to the games. So when I first moved out of my parents' house, I had boxfuls of stuff. And one of the boxes was a whole bunch of Phoenix Suns tickets that I would go get the tickets. Never went to the game, because it didn't cost me anything going to 7-Eleven and get 2 free tickets. But nowadays they don't really do that as much. But there are definitely programs out there, and I imagine the Rockies. Didn't the Rockies have the lowest attendance at one of their games this past season? Am I thinking my year's correct? Where it was something like 600 people total went, and that might have included both teams.
I think that's partially due to the temperature.
The temperature, that could have been. So yeah.
I thought the Rockies had like really high attendance, even though they're like really bad, but they have really high attendance.
Yeah, but there was one of the games. It was like the lowest. But
last season, like the summer.
Maybe sometime during the summer. But then there was another team that just beat it close to the end of the season. I mean, when you get down to the end of the season and your team doesn't have a shot at making it, your attendance is way down usually. Unless you're the Cubs and you always know that you suck. But they always have high attendance because it's the Cubs. But I don't know, kind of interesting. So friends, between today and tomorrow. So today, I'm not going to give you an assignment. I mean, we're just about on fall break. I obviously don't have anything for you to do over fall break because no teachers are supposed to assign anything over fall break. And that does not mean if you had makeup work that a teacher can't assign you makeup work. But we are progressing pretty well through this stuff. I think when we get back to school on the Monday after break, what we'll do is we'll probably do the 2.4 to 2.6 review, and then I'll do 2.7, and then we'll quiz on the Wednesday after break on 2.4 to 2.6. And I was talking to Mr. Anderson, he's like 4 sections ahead of us, so I don't really worry about he's ahead of us or I'm ahead of them. Doesn't matter to me. So it all seems to work out. So that's all.